Good day, ma'am. I am Marco Chinlinate, and this is our video for final requirements in your subject physics. Thermodynamic system. It is any collection of objects that is convenient to regard as a unit, and that may have the potential to exchange energy with its surroundings. A familiar example is a quantity of popcorn kernels in a pot with a lid. When the pot is placed on a stove, energy is added to the popcorn by conduction of heat. As the popcorn pops and expands, it does work as it exerts an upward force on the lid and moves it through a displacement. The state of popcorn changes in this process since the volume, temperature, and pressure of the popcorn all changes as it pops. A process such as this one, in which there are changes in state of thermodynamic system, is called a thermodynamic process. A thermodynamic system includes anything whose dynamic properties are of interest. It is embedded in its surroundings or environment. It can exchange heat with and do work on its environment through a boundary, which is the imagined wall that separates the system and the environment. The burning gasoline in the cylinder of a car engine is an example of thermodynamic system. There are two systems, the closed system and open system. So closed system, it is a system called isolated or closed system if it is completely separated from its environment. So open system, it is opposite of a closed system which involves the environment. It exchanges energy with its surroundings. In closed system, for example, a gas that is surrounded by immovable and thermally insulating walls. A closed system does not exist unless the entire universe is treated as the system. Open system, for example, the boiling tea kettle is an open thermodynamic system. It transferred heat and matter to its surroundings. Before we carry out any study on a thermodynamic system, we need a fundamental characterization of a system. We should examine the heat transfer between a thermodynamic system and its environment, and its balance should dictate the thermal equilibrium of the system. So when we say two objects, a thermodynamic system and its environment, are in thermal equilibrium, we mean that they are at the same temperature. So how do we know whether they are in thermal equilibrium? So the governing principle here is the zeroth law of thermodynamics. As prescribed in temperature and heat and temperature and heat, if object 1 is in thermal equilibrium with object 2 and 3, respectively, the object 2 and 3 must also be in thermal equilibrium.